Good morning and most welcome to Heidegger 1404. We will today take up an article by Alan M. Rehn, The Role of Consciousness in the Origin and Evolution of Life. This from a collection of works edited by Ingrid Fredriksson here in Sweden. I will compare the rather complicated and equation-rich article of Alan with two aspects, interoperability and entanglement. And I will directly read from Chiara Marletto to compare to ease understanding this rather difficult matter. I will start with a readout from the article. We have here The Role of Consciousness in the Origin and Evolution of Life. Abstract. During the origin and evolution of life, there were a number of essential large steps that had to take place in addition to a more or less steady evolution. Common to those steps is that no known mechanism is efficient enough to make them happen. In the present paper, a super-Darwinian approach will be taken in an attempt to make it plausible that life and evolution towards a conscious species is possible. An example of the obstacles is that a self-replicating peptide has has to be smaller than 37 units for life to be probable on Earth. Or less than 111 for the entire universe. This could be compared to the smallest known RNA sequence able to copy another molecule being 165 units long. Furthermore, the initial genetic code had to switch into the present DNA-based one. As the original code probably was very different. Switching from one to the other was extremely difficult, similar to an evolution of Chinese written language into English. Thus, intelligent life should not be able to appear anywhere in merely 14 billion years. As we are here, however, there has to be some mechanism that makes intelligent life possible, unless we are created and developed in a supernatural way. the super-Darwinian theory presented here. Life has been able to overcome the evolutionary obstacles by taking advantage of the fact that consciousness coupled to matter appears to be required for the quantum mechanical wave function to collapse. When energy is converted to matter, the particles form entangled states. Such states persist until a measurement forces collapse of the wave function. Very important, I will repeat it. When energy is converted to matter, the particles form entangled states. Such states persists until a measurement forces collapse of the wave function. Consequently, one could expect that the entire universe was in a state describing all possibilities simultaneously. Among all those possibilities, there should have been a huge number in which life was initiated at different locations in the universe. Then the potential instances of life have undergone evolution. Each each of the successful evolutionary routes will lead towards a particular kind of intelligent species, humans being one of them. Other routes would possibly have been developing towards very different kinds, like intelligent insects or stranger species like Donald ducks, trolls, or even an intelligent species built from interstellar gas clouds. The parallel processing would make evolution fast enough to overcome the difficulties mentioned above. Different branches of evolution would proceed at different rates. Finally, there would appear a species with a brain intelligent and efficient enough to handle consciousness. The universe would have produced a conscious observer, and its wave function had to collapse. Instantaneously, all other branches disappeared. This super-Darwinian mechanism would cause extinction on a far greater scale than any other known. Actually, there would be no fossils left from erased branches. They were erased not only from continued existence, but even from history itself. There are at least three ways in which this super-Darwinian theory could be disproved. One of them being that if intelligent life is found anywhere else in the universe, the theory is probably wrong. Introduction. As noted earlier, during the origin and evolution of life, there were a number of essential large steps that had to take place in addition to a more or less steady evolution. Common to those steps is that no, no known mechanism is efficient enough to make them happen. First of all, there is the fine-tuning of physical properties in the universe. The most reasonable explanation for that is that the universe has been created with the purpose of being inhabited by living organisms. There have been several attempts to find alternatives. But they all appear to fail in some way. Some of those theories require the constants of nature to be able to have a huge number of possible values, if not infinite. Furthermore, they would require a multitude of universes with different sets of constants and properties. There is no evidence whatsoever for the requirements to be fulfilled. There is also no mechanism proposed that would prevent one of the universes to have a set of constants that would cause it to break free and destroy all the others. One could also state none of the theories include a kind of physics that gives rise to consciousness as we observe it. Secondly, life started somewhere in the universe and probably upon the earth. Current theories on the origin of life could at best be considered as suggestions. There is a lack of evidence, and most of them make use of steps that makes them very unlikely. An example of such problems is that most of the theories ignore the fact that peptide bonds are not stable in aqueous solutions. That is water, I comment. And as a consequence, peptides do not form spontaneously in a solution of amino acids. Further problems are the large information content in even simple living organisms. The rapid establishment of the DNA-based genetic code and the rapid evolution of life to form increasingly complex and efficient species culminating with mankind. In the present work, a super-Darwinian approach will be taken in an attempt to make it plausible that life and evolution is possible. In this theory, it is assumed that the universe developed according to the quantum mechanical laws, with the wave function dispersion going on where interactions did not occur. And the output channels staying open during creation annihilation events. As well as collision events and other kinds of interaction events. This is of great significance. Do remember the difference where interactions takes place and where they do not take place. I think from an ordinary perspective, we never make that difference. And that sort of dilutes understanding of the quantum world. Reality only becomes collapsed into a particular thing when interactions happens, not when they are not happening. This caused evolution to proceed at rates orders of magnitudes faster than would be possible according to classical mechanics. When evolution had resulted in a brain complex enough a filtering of the universal wave function occurred, and the less successful forms of life were extinguished. What Alan Amrian mentioned here is close to the view of information that David Deutsch and Chiara Marletto has. For them, information is, just as we said, interaction, not before. Listen to this from page 87, second paragraph. Interoperability is due to the fact that all information media have in common properties. The two counterfactuals I mentioned above that transcend most of their specific details. You can compare that to the bifurcation I mentioned earlier. An interaction or no interaction. Whether they are photons, transistors, the spins of an electron, neurons, or switches in a lamp. In all these cases, when interested in the information processing abilities of these systems, we can abstract away their irrelevant details and simply talk about them as information media, considering their information carrying attributes only. And examples from Sentosa Island and the bridge were up and down for an arrow, on off for a lamp, and so on. I've written the aquatic term, well, among other uses of bifurcation. There is actually a bifurcation in this very county, on Hising Island. It doesn't part, but at some point in the stream it changes direction, going from one to the other. And where that happens is always in flux. The bifurcation is between interaction and no interaction. And as I pointed out earlier, this is a very big difference in contrast to classical physics, where we make no distinction at all whether something happened or didn't happen. From a viewpoint of quantum mechanics, that is extremely weird, because that difference is very important. It is what makes things be. They need to interact. There need to be an observer, as we usually say. And that causes the bifurcation to part into two definitely counterfactual states. And this is building up information on, off, as the lamp in Sentosa. Having two states makes it possible for the lamp to carry information. One state, as in the classical notion, doesn't explain information the whole way. And therefore it still remains in the paradoxical dualism of Cartesianism. This can also be compared to the Heideggerian expression aletheia and theia, covering, uncovering, or also in the words of David Bohm, at least my interpretation of David Bohm, is that the explicit and the implicit partake in the becoming of what is. as you can see, I compare this to life in Emrean's depiction. The differences makes for more and more complexity. In the end, and this is from Emrean, the complexity chooses how the bifurcation develops. This last part is Emrean's exploration into the bifurcation, so to speak, and development. Question, I think we remove this here too.
Hello, hello. Let me paint. We put chicken, egg, a slash. Let me also put human slash this is our slash, so it's like that. So let's say for Allan, if I understood him correctly, the wave is the origin of everything. So the quantum physical wave. And in this, so this is the origin of universe. And when you think about the chicken egg problem, what is primary? Is it the chicken or the egg that is primary? In quantum physics, both come in being at the same time. And perhaps also we could say in the division, in Darwinian division, that ape comes first and then it develops into human. But in quantum physics, perhaps they came at the same time. It's like a wave between them. So you usually think in terms of, say, slash. So chicken slash egg. So we are discussing what came first. And here, what came first. And then slash means also cat. So this, as soon as they come into existence, there is a fight, so to say, between, let's say, what come first. And it could be useful perhaps to think this as a wave, not to see a harsh opposition between these. But I think more useful is perhaps we could leave the slash, is to imagine like a wave going above them, and then upon observation it collapses, then you have human, or in some cases you have ape. So I don't think, so what is primary in the universe, Hans? What is your take on this? Did I misunderstand Allah completely?
Well, they seem to be coming at the bifurcation is simultaneous. So, yes, I would say they come into existence at the same time. In some cases, we benefit and we make a distinction, but on a foundational level, they are, in a way, miraculously simultaneous. And so is the split between matter and mind. It is there afterwards. We are more than welcome to make a distinction. Possibly we can benefit in some cases. But we need to remember they spring into being in a movement that is oddly simultaneous. It happens at the very same time. Thereby we have answered the question of chicken and the egg. I continue a little bit reading from Anna Nemrén. Origin of life. There's no agreement on how life emerged on Earth. Some authors even find the probability for this to happen so low that they assume that life has started somewhere else and have spread in some way across interstellar or even intergalactic space. Most hypotheses, however, assume that life has started by simple organic molecules being dissolved in water. It could be the ocean, some lake, or a pond. In this environment, the molecules have reacted to form chains like peptides, RNA sequences, etc. By chance, one chain thus formed would be able to replicate, and life would be running. Once such a chain was present, it would undergo Darwinian evolution. Increasing the level of complexity. finally, billions of years later, the present biosphere would have formed. Prebiotic life. As mentioned above, it has been proposed that life actually did not start on the earth, but at some place in the universe where the conditions were more favorable. After life had formed there, it would spread spores or tiny seeds across the galaxy. It has even been proposed that seeds or entire organisms have been transported by purpose in spaceships and planted into other worlds, the Earth being one of them. There are several arguments against this kind of hypothesis. First, it is difficult to imagine an environment more favorable than the early Earth for formation of primitive life. The temperatures were in a range where chemical reactions could proceed at reasonable rates, while not high enough to prevent formation of complex molecules. Furthermore, the reducing atmosphere protected organic molecules from being oxidized to water and carbon dioxide. Secondly, life could not form in a very young universe, as the elements available during the first billions of years were merely hydrogen, helium, and lithium. No carbon, no nitrogen, no oxygen, no sulfur, etc. Such elements are formed in the centers of stars when their fuel has been consumed. If a star is large enough, it will explode violently, and the elements in its interior will be spread into space. From there, it is able to serve as raw material for high-density planets like the Earth. Thirdly, once life had originated, there should be a mechanism that makes seeds in huge quantities leave the planet and the solar system in which they were formed. When they had entered interstellar space, they had to survive a very long journey without being destroyed by radiation. radiation doses collected during millions of years in space are huge, and it looks more or less impossible for the genetic information to survive even in a dry and frozen state. Considering such facts results in the conclusion that the most probable place for life to have started would be on Earth itself, some 3.5 or 4 billion years ago. The building of materials, simple organic molecules like amino acids, may have formed in the reducing atmosphere through reactions driven by electrical discharges of UV light. They may also form in space, where the reactions may be driven by UV and gamma radiation. Then they could have reached the Earth via comets and dust from space. And now there are chemical formulas. Although I do like chemistry, I will not impose them on you, dear listeners and viewers. You're welcome to check them out yourselves. I go to page 90, the third paragraph, evolution. As soon as the prebiotic life had been initiated, it probably also started its evolution. The dominant theory at present is that of Darwinian evolution. Other theories have been around, but they have not been as widely accepted. A problem common to all such theories, including the Darwinian, is that none have been proven and ways for falsification have not been proposed. To take Darwinian evolution as an example, whenever it has been found that some property is of advantage, this has been looked upon as a support for the Darwinian mechanism. When, on the other hand, some finding appears to contradict the theory, it is supposed that the problem will be resolved in the future. Or by some minor modification of the theory. This is a phenomenon that has occurred many times during the history of science when a paradigm shift is about to happen. Darwinian mechanism. The evolutionary theory of Darwin has been modified gradually as new facts have been found. Possibly the most dramatic change took place when the mutations were discovered. this meant that rather than a continual change of properties of individuals, the properties were found to change in discrete steps. The steps, however, could be small enough for the evolution to proceed in almost smooth ways. With mutations, however, there was also the introduction of possibilities for huge steps to be taken at once. So in the evolutionary process, not only the direction of change was found to be random, but also the step length. This is also sort of very pertinent. Discrete steps and a smooth evolution are traits from the Newtonian paradigm lingering on, seeing evolution as a movement on the coordinate system. Later, it was found that entire genes could be transferred from one kind of organism to another, and also that in some cases the environment could cause the genetic properties to change in non-random ways beneficial for the species. This transferal between organisms is called horizontal transference, and it was an important discovery. One could summarize the Darwinian process in the following steps. One, a random number of mutations take place in the genome of an individual in a certain population. The mutations take place at random locations in the genome. 3. The mutated genome is transferred to the next generation. 4. As a result, the new individuals will differ in their ability to mature and give rise to a new generation in the present environment. The differences in that ability may be extremely large, but generally the effect is small or almost negligible. Five. In the next generation, there will be a slight increase in the number of individuals with favorable genomes as compared to those with less favorable. Six. After a large number of generations, the population becomes more efficient than originally. I now go to page 100, the second paragraph, brain and wave function collapse. Obviously, consciousness is tied to the brain in some way. If the brain of a person is caused to be out of function, consciousness disappears as well, at least as seen from an external observer. This suggests that consciousness is a process going on inside the brain. Walker suggested that consciousness is caused by quantum mechanical phenomena like tunneling among the synapses. This could be a possibility. Another possibility is that parts of the brain rather are kinds of receivers and transmitters that are able to connect an immaterial consciousness to ordinary matter. If so, consciousness itself dwells outside the body, perhaps even outside the physical universe, something that is not impossible in Walker's model either. Whatever the connection is between consciousness and brain, this connection gives us possibility to interact with objects far from ourselves and with past times as well. Once, however, the collapse has taken place, the process is irreversible as far as we know. Possibly, this is the true arrow of time. Before the collapse, time might be able to proceed in any direction. But when the collapse takes place, it is impossible to move back to an earlier event to change it. So once more we are entering into the domain of collapses and entanglement. As we mentioned earlier, information is a result of the contradistinction between what happened and what did not happen. This is closely tied, my pun, to entanglement. I will read this from Chiara Manetto's book, The Science of Can and Can't. 125, the third paragraph. Entanglement is one of the most exotic and powerful and misunderstood properties of quantum systems. When its properties were fully discovered, it soon became clear that it would revolutionize the way we understand composite quantum systems. That is to say, systems made up of two or more subparts. The concept was already known to the pioneers of quantum theory. Schrödinger is usually credited with introducing the idea. But the full potential of entanglement-based ideas was unleashed in the early days of quantum computing. When that was first considered as a resource for quantum computations. The physicist Vlatko Vedral, who in the 1990s pioneered our most subtle measures of entanglement, often jokes about the explosive development of the field. Remarking that he could manage to get an academic job simply by working on the foundations of this elusive and fascinating quantum phenomenon. Entanglement arises when you have two or more quantum entities interacting. For example, two photons or an electron and a photon. The essential feature of entangled quantum systems is that the information one can gain by jointly observing the systems is more than the information obtained by observing each system separately. This phenomenon is rather counterintuitive and removed from every day of experience. So stop the introduction of this most interesting here. Put in a little pause. Entanglement. If you listen to the lecture in quantum biology or any of the episodes by Jim Al-Khalili, where he mentions the robin, who by entanglement can locate the very, very small and almost forceless magnetic local latitudes, thereby navigating the skies. You know that the robin makes use of both one photon that enter his or her, I think it was the left eye, and that photon's entangled twin. And I would use the term that is out there, but that is not absolutely correct. But thereby it gets conscious of where it is. So think about the traditional way of seeing at consciousness. It's a sort of direct viewing. I see B, for instance, and it's absolute. I can only get as much information from the thing I'm viewing that is actually present in the thing. This is not true. This is an everyday intuition that I would say is the most normal one. But Vlatko and a lot more scientists today are working on a model that goes directly against the idea of bijection. Much more information can come. And this is what consciousness is in Amrien's view. The extra that comes from using the more proper model of entanglement, which says that there is a lot more knowledge, information and consciousness which more or less amounts to the same than is in the actual object as well as the subject. It goes well beyond. It's an endless source, and it can be used more if the intellect can learn how to use bifurcations to develop more possibilities for understanding. This goes at the very grain of what the old model is saying you cannot gain any more information than it's inherent in the thing that you look at. I think one question that should pop up in your head is this somewhat similar to the discoveries made by Alain Aspect and Clausinger and Salinger, who won the Nobel Prize, that global reality is what gives the local reality. Yeah, there is a connection here. It is all down to this mysterious tendency of entanglement. And once more we have the famous bifurcation, and after the collapse you will in this example have two electrons one spinning clockwise and the other spinning anti-clockwise, and they will simultaneously show the same behavior but in the opposite rotation. They are twins after the collapse. It's even so you can say that there is an infinite potentiality for knowledge. So to make a short recap, in Amrien's view, the bifurcation made it possible for primitive life to evolve. Then you can take it to this more complex level and see that consciousness, a form of counterfactual, continues to grow out of its skin made by evolution beyond the body, so to speak. We are breaking the chains of the Newtonian paradigm, literally, at an individual level, going beyond. This is similar to a process of becoming. Heidegger would call that presencing. And I also like to compare it to the not present in the Derridian aspect, where the shift is the interesting part, and not only that state or that state. They are literally entangled, although completely different. In difference lies information, clockwise, anti-clockwise. Maybe a comment?
Thank you. So let me. So what is Alan offering us? He is offering a Darwinian theory. That is his own term that he has created. He doesn't really, so to say, explain super itself. You could think it's like in everyday language, super something great, excellent. But I suppose he means super in the sense of being above, like consciousness. So you say that you have the evolution here. If you think about the normal linear approach, where you have, let's say, the ape and the human beings, etc. And then you have supra, above it you have the supra, super in etymological sense means above. So the consciousness would be in some say above all this, super above. So to say, be watching this evolution. If you would take the linear approach, even if you don't take the linear approach, say, let's say, like the ape and the human being with a slash, whatever case. So, but I think Allah uses super in many different senses, like excellent or super, that is one, like 2.1. So this is the new Darwinian, new Darwinian theory updated to 2021 or 2050 or whatever. Or super, like above, so the consciousness, so to say, hovers above, so somewhere there. So where is really consciousness in all this? I don't know yet if he has an answer, Alan, as far as I can see. Anyhow, he says that it could be outside the universe, it could be inside. So if you compare with the Rose model with the tennis player, so it's the tennis player who makes the superpositions collapse all the time. Would Alan and Ren agree with this? I don't know, perhaps. I don't know if I still get his point, so to say. He speaks about great jumps in evolution that's problematic. Perhaps you can straighten out my perplexities, Hans. What is his point really so far?
Thank you very much for your comment. Very good. This is the first leg of the lecture. Cover the lower level, and now we are in the above, the development of consciousness itself. And it leaves its bodily costume, so to speak, its limitations, by sort of like the red robin using a feature of the world to its advantage, but even still more. And consciousness is this extra doses of knowledge, understanding, and it goes beyond. My guess, what Alan is pointing to, is, if you remember this view, which is held by Descartes, that the consciousness is exactly the same as the thing viewed. There is no difference whatsoever. Entanglement shows it goes way beyond that. It is much more. And in a way, although Descartes was defending consciousness, if you like, he reduced it involuntarily to the outside world, and clearly, I would say, established the bijection, the representation. Both Marletto and Deutsch means that information is definitely much more than this, and also shown by quantum computers. And we use this to get extra information. That's a hint to what Emrien is pointing to. Any more?
Yes, I think I got an idea.
Just check the time.
Yes, let's check out. We can finish this with a short remark. So let me see. This is. Let me think. So let me think about this. Let's continue with. I was thinking about super, this super, and what you mentioned, Descartes, like. Or we could take the most obvious case, brain development. So let's say that you have the human being here. This is like say me. So you have. Let's say that. Where would you say that? Okay, no, the brain is somewhere here. Say like that, or you could say it's actually in the brain development. It's like here, but everything else is irrelevant. So it's like that. Let's say brain development. My thinking is only here. What I do with my hands doesn't have any relevance at all. Does it? Do you see it? Yes. So this is so. So what I do with my hands in this brain development theory doesn't have any significance, but we know that's not correct. And that was also Descartes' position, more or less. Although he was also disposed to think that the thinking is already also here, hovering somewhere here. Not defined, but his body, what he did with his body, didn't have any, didn't play any role. And where do we have this super? But I think Alan, what he does, he says that when consciousness is tangled with matter, then the superposition collapses. So the matter is necessary in Alan's theory, which is really great, or super. Let's say now we try to defend Descartes. We could for once defend him. So you have his thinking here, but his thinking works only. Okay, he can have ideas B, C, whatever, like a cat here, dead and alive, but it works only once it collapses. It goes together with the matter. But the thing is that when he thinks, he can only think in either or. So it's a problematic position in any case. I don't know if I made myself clear. But how would we put it? So thinking is always relative to matter. Let's continue with this in another lecture.
This is we're finishing up here, but very good. I see what you mean, Kalle. You grasped it directly. I would say until you get into entanglement, the brain in the vat is the only solution. But once you get into entanglement, you see it's not necessary for that limitation to be present anymore. And this is exactly what happened in information techniques by the 1990s. They discover this enormous, I'm going to use the phrase that, of potential information that is almost infinite. And I would say, and agree with Stuart Hammer